Yeah, thanks for being here with me today. I knew it was going to be a tough spot, the last one of the day, but hopefully we can have a bit of fun before we all head off to the pub or whatever we do after this. A little bit about me. I'm from New Zealand, or Aotearoa, if you're wondering. Oh, so a bit weirdly format. I'm the former co-founder and CTO of Compago, which was acquired in 2023 by Elements Group. I currently work as DevRel for Aikido Security. I'm a former developer, DevRel at Git Guardian, which I think most people know me for. And I now live in the Netherlands, just to keep everyone guessing as to where I'm going to be in the world for the moment. So I knew that I was on last today, so I decided to run the presentation, 50% presentation, 50% memes. So hopefully we can get through this with not too much issues. But this was kind of like something that I was thinking about. Injection attacks are like what we consider to be more or less a solved problem, yet they aren't solved at all. And so this was something that kind of interested me, so I decided to do a little bit of research into this and kind of found some stuff that perhaps you will find surprising or won't find surprising. But the history of SQL injection, so it was first kind of coined. I've got or discussed publicly in 1998 by Jeff, known as Rainforest Puppy. Some facts about 1998, web developers were called webmasters. That one was funny because I tried to explain this talk to my dad, and his question was, don't webmasters understand that problem? And I was like, well, maybe they did. But Google wasn't founded yet, Napster wasn't created, and open source wasn't being coined. So the point of that is that SQL injection has been around for a really long time. Yet, for whatever reason, it is something we are still really struggling with in security today. So, I'm pretty sure you all know what SQL injection is, but just in case, I will go over some very, very basic examples of it. It basically happens when untrusted data, so user input, gets injected into an SQL query. And most of the time it allows things like authentication bypass, data exfiltration, or remote code injection in some extreme and very bad cases. So how does that all work? Basic SQL injection, we've all seen it before. But basically, if we have something like a login screen here, this is running a query like this in the background, where it's taking the username and the password of the user input directly and running it inside the query, which means if we do something like this, put admin dash 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 dash, we're basically commenting out the last part of that query, and then kind of bypassing the need to verify that we're checking the password. So this is kind of the most basic authentication bypass of SQL injection. But we all kind of understand exactly kind of how this works. And of course, we can have long discussions about very complex versions of SQL injection, but they're mostly the same principles. We're taking untrusted data and we're using them within our query. And there's various ways that happens, but the basic principles generally come down to all being, the same thing. And then we're able to kind of log in. So this is just a very dumb example of the most basic version, where if we just use admin, then we can log in to an admin of here. And this is really stupid because I'm sure no one's impressed by this and would all thought that this wouldn't actually exist in the real world. And that was at least my thinking as well when I started looking into doing a little bit of research to find out, hey, where are we at with SQL injection? Because everyone is still kind of talking about it. But how do we fix this? Well, this is one of the other parts of it, is SQL injection is more or less a solved problem with defined statements or prepared statements, prioritization. And so here, instead of taking the user input and using it directly, we're preparing our statement, we're sending that off, and we're sending off the user input separately. And why that's important is the user input is now treated as strings, and it's not treated as part of the query. And so this is really simple, and this basically solves 99% of SQL injection kind of like issues and causes. Obviously, there's some people probably squirming saying, yes, but what about dynamic columns and other things? And yes, there are some other examples by here where we're using things like untrusted user data to sort things. If you have a sort list, then that can also be SQL query. And there's some ways that we can avoid this, but things like parameterized or prepared statements really solve most of the issues around SQL injection. And for the other kind of dynamic column ones, then basically it's about creating kind of allowed user inputs on the server side. Some people still seem to think that client-side validation is how we fix SQL injection. I can tell you that it's not. All validation needs to be done on the server side. And creating allow lists is far more effective than creating ban lists. I've also seen that a lot, where people try and ban the kind of SQL injection, but people can be very creative, and there's a very long list of injections on edge cases that will work in some cases. So this all should be fairly easy, right? Like, we have SQL injection, we use prepared statements. We discovered this in 1998. We discovered prepared statements like 1 year later. So surely this is going to be a boring talk and we can all head down to the pub. That was at least my thoughts as well. And I went out and said, okay, how big of a problem is SQL injection today? So I went off on a little bit of an adventure to try and find this out. And what I found will probably not surprise you all that much. But just to explain my research methodology, first, I wanted to look at closed source and open source projects. So I wanted to look at all the CVEs that were published for open source projects in the GitHub Advisory database. Was a database that I used just because it was the easiest one to kind of query. I explicitly looked for these types of CWEs. And then I also reviewed 70,000 closed sourced projects, or the initial scans of 70,000 kind of projects that were closed source. After I did SQL injection, I was quite surprised by the results, so I moved on to command injection and path traversal, and also did some research into looking at how prevalent are they still today. Some quick considerations with my research is the closed source projects is limited to Aikido customers. I work for Aikido, obviously. So we took the data from there. So this means that we're somewhat limited in the closed source areas, but we still were able to use 70,000 customers there. And there's also some other areas is that because this is a modern security tool, legacy tools often aren't really integrated with modern security tools because it will just give everyone nightmares and no one's really going to fix it anyway. So we probably are missing a lot of results there. The people that are kind of using things like Aikido are probably a little bit more mature, so they might be a little bit better than average. So this is kind of giving us, all this is to say, this is going to give us an indication of the posture, but it's not an exact view. The exact view is probably a little bit worse. So what did I discover? I discovered that SQL injection is still very much a thing in 2025, and that actually it's pretty much everywhere still, and still makes up a huge proportion of the total vulnerabilities that we have today. So what did I find? If we start just by looking at open source projects, SQL injection just in open source projects, in 2023, there was 2,264 SQL injections reported, 2,400 in 2024. This obviously comes from the GitHub Advisory database, and below that we have the total number of vulnerabilities. So if we express that in a percentage, still close to 8% in 2023 of the vulnerabilities reported in open source were SQL injection, 12% in closed source, and we're getting slightly better last year, but I was still very much surprised to see that there was 10% of the vulnerabilities that we found in closed source projects to be SQL injection. And this was really quite surprising to me. And the number that really stood out to me was that 20% of all closed source projects contained at least one SQL injection vulnerability on their initial scan. So when we first rolled out scanning into the database, 20% of the projects had an SQL injection vulnerability within it. So this was probably the most surprising stat that really stood out to me as to where we currently are with SQL injection. So what about SQL injection's kind of cousins around here? And some people may be thinking, well, if I don't have an SQL database, I can't be affected by SQL injection, and that is explicitly true. I didn't quite go into NoSQL injection here, but that's something that I will look at. But I started looking at command injection, and the results here were also very, very surprising. So a quick recap, like what is command injection? Basically, here, it's very similar when you take and you manipulate untrusted data, user input, and you're trying to get back to execute system commands or OS commands. And so basically here we have a stupid example where we're connecting back to retrieve a file from the system. You can select 3 options. This has client-side validation, so obviously it's very secure. And then it's retrieving that file through some commands. But if we were to do something like this, and at the end of it, select dog, and now we're removing all the files in that directory. So this is what a command injection can be. And obviously here we can just bypass the client-side validation and just cause havoc on the screen by executing commands. And this is a stupid example, obviously, but you can use your imagination as to kind of how bad this can get. So what about command injections? How bad was this? Expressed as a percentage, this is actually worse than SQL injection. So we found just last year 2,610 vulnerabilities in open source projects as reported on the GitHub advisory database. And if we look at that kind of as an expression here, if we focus just on last year, we're still at around about 7% of open source projects, of all the vulnerabilities that were discovered, were a command injection, as opposed to 5.8%. So we did see a bit of a drop there in closed source projects. But still, this is very surprising because these are what you would kind of consider to be quite basic injection attacks and basic security issues with very well-established, well-documented ways of how we don't do this. It almost feels like you have to kind of go out of your way to introduce these vulnerabilities in your projects, but clearly it still happens. How do we kind of fix command injection? I won't go too much into this, but again, server-side validation, creating allow files, and also making sure that you're avoiding shell commands. For example, if you're retrieving documents, making sure that you're doing it in read-only, so limit your what you can do. And then finally, the last one I looked at is path traversal. And so this is another one of what I would consider kind of the SQL injection kind of cousins here, where they follow very similar methods. Path traversal, still very prevalent, especially with things like file uploads, handlers, and areas like that, or retrieving files. And it's very simple. We have here a variable that's expressed in the URL. In this case, it's report.pdf. And we're explicitly taking that in our code to retrieve that file. And then we can do something like this, which will basically allow us to get out of that directory, go back to the root, and try and access things like a password file. So this here is obviously, and this is quite prevalent out there, and again, something that should be quite basic of what we can do and is well established of how we prevent this. This is much less common than what we saw, but in open source projects, last year we still found 1,000 vulnerabilities that were path traversal in there, and expressed as a percentage, the path traversal vulnerabilities still account for 2.7 and 3.5% of all the vulnerabilities we find retrospectively. There's multiple ways of which we can do this. Again, it comes down to input validation, sanitizing, stripping out characters that could be dangerous. But it's very well established, and none of this is all that complicated. So again, it's quite surprising that this is so prevalent in the modern era of what we're dealing with. And what's also really surprising, if we take the total impact of just these three vulnerabilities that have been around for a long time, that are well documented, that have well-established ways of how we don't implement this. If we look at the total effect that it has, we're at nearly 20% of all the vulnerabilities we find in closed source projects fit into one of these three characters. That is an absolutely huge percentage of very, I guess you could say, basic vulnerabilities that we find, and 16% in open source projects as well. So it is interesting to kind of see how we still are struggling so much with these basic areas in our coding. And I think this is quite surprising, at least it was surprising to me, that we're still dealing with this. So what is the real world impact? It's all very well looking at GitHub vulnerabilities and finding issues inside your closed project things, but perhaps they're false positives, perhaps we're just using really shitty scanners, or perhaps they don't have actual impact, all of these kind of questions. But this can be reflected out in the real world when we can see, for example, the Move IT breach. This one was particularly bad. It happened in 2023, but it had a resurgence in 2024 because in 2024 we started seeing a lot of the data and things exposed from that. This affected 62 million individuals from it, and was ultimately due to an SQL injection vulnerability in the Move IT. Now, Move IT or Move It is a file transfer protocol system that was being used. I'm not super familiar with it, but it's used by a lot of people, apparently. And so this kind of goes to show that even basic injections can be part of, basic vulnerabilities can be part of massive projects out there affecting millions and millions of end users and customers. When it comes to path traversal, we've also seen a very bad one in the ConnectWise one. This had very mass exploitation. This one was interesting because it was actually discovered, it was reported to a CVE, and then after it was reported, then we started seeing the mass exploitation of it. So it was due to the fact that the attackers were able to look at this. It was a critical CVE with high exploitability, and so they were able to use this and basically find out anyone that's using kind of older versions of ConnectWise and able to exploit this. And there were some very high-profile people like Lockbit, the ransomware group, that were exploiting this vulnerability. So it goes to show just the scale of what we can still see in these simple vulnerabilities. So why on earth are we still struggling with this in the modern era? How come we're not getting past this? Well, there's quite a few reasons kind of why this happens. Some is legacy platforms. We're still dealing with a lot of legacy code out there. If you just go to any bank and realize that everything's still written in COBOL, then we'll realize just how much legacy debt we're dealing with. There's an over-reliance on tools like WAFs or in-app firewalls, where people seem to think that they will catch everything, but there are very defined rules around what actually is caught in WAFs, and it's very, I'm not going to say easy to get around them, but you can certainly not rely on the fact that they're going to catch everything. AI-accelerated code is something that we're seeing that is increasing this risk. I have a couple of slides coming up about how AI code, or AI coding, or vibe coding, as it's now being called, is kind of increasing the vulnerabilities that we're actually creating. And then there's also just kind of shitty code. And there's various reasons of why we have this. And I think some are not to blame the developers on this. I'm sure there are reasons, but I think the bottom line is that this isn't a technical problem anymore. It's a cultural process and an education problem. That's what we're dealing with here, because these are all solved problems, at least from a technical point of view. So it's really kind of dealing with the culture of this and understanding how we're moving forward to be able to get rid of these types of vulnerabilities. Now, there are lots of tools that we can use to help us with this, and I think you can bring it down to kind of a couple of areas. So one is shifting left. So these are using tools like static application security testing, code scanning, dynamic application security testing tools like ZAP to help us actually run tests on our applications to make sure they're not vulnerable. And then also using software composition analysis. Software composition analysis is looking at the dependencies that we have And in some of the examples that I gave you in the real life examples, it's because applications were vulnerable because their dependencies were vulnerable to these types of attacks. So using something like SCA is really important to make sure that our applications aren't vulnerable because of a dependency that we're using, or even a downstream dependency or transitive dependency that we're using isn't vulnerable to this. And then on the other side of that is kind of the shift right. And I know that I was talking about WAFs before, web application firewalls, or RAS, or sometimes called in-app firewalls. These are still an important part to have in the strategy because we can't be 100% confident that we're never going to let anything slip through the cracks. We can't be 100% confident that the static tools are going to catch everything. So having that on the other side of it, having that shift right component is really important to making sure that we do stay up to date in everything that we're doing. So what about AI code and AI coding assistance? Well, there is some research that came out. This is a one from Cornell University that looked at the type of vulnerabilities that AI is actually introducing and then compared them to a baseline, or in this case, a human. And what's really interesting here is that although the LLMs are quite bad at some types of vulnerabilities, for example, authentication, even padding, maybe some buffer overflow, when it comes to injection, they're actually much better than humans at the moment, at least according to some of these research studies. Now, this is kind of in conflict with a lot of what you see out there because everyone loves to show an LLM giving you an SQL injection kind of vulnerable type code, and it certainly happens, and I will show you some examples of that. But what we can see is that these tools have some potential, at least potentially solving this issue, and especially when we introduce them or start using them into things like our vulnerability scanning. So I did a little bit of an experiment to try and see how I could get an AI coding thing to create some vulnerable code for me, and what would it take. And so what I did is I took this prompt and ran it several hundred times and evaluated the responses what I got, and then evaluated how many of them were actually vulnerable. Now, the reason why you get a different kind of response every time you run a prompt is that there's something called model temperature. And model temperature can either be kind of hard-coded into a specific model if it's designed to do a specific task, or the model temperature can adjust based on the prompt. And all model temperature means is the variance or the entropy in the answer that it gives you. So basically, if it has a high temperature, then you've got to have a high chance of getting a very different answer each time. If it has a low temperature, you're going to get nearly the same answer every time. And so when I ran this, I did this experiment in ChatGPT as a baseline, and 12% of the code that it generated from this same query was actually vulnerable. And quite a few of them were vulnerable to things like SQL injection. This was the worst one, of which one of the worst ones. It gave me this kind of output several times. But this one here was what I considered the worst because it was so obviously vulnerable to SQL injection, because if we look, we can see that it's directly taking the user input and running it inside the query, and it's not using prepared statement. What I found really interesting here is that this is kind of like is very indicative to what we're seeing out there in the open source space, where the amount of vulnerable code that I got from ChatGPT was almost identical to the amount of vulnerable code that we see out there in the open source space. So it kind of goes to show that these models are taking a lot of their learning and logic from these open source models. So therefore, it does seem to translate that does bring them into your responses. So whilst AI code assistants definitely have promise to help us out, we have to be very skeptical on our reliance on them to help us solve these problems, like SQL injection, going through and moving on into the future. So how do we solve this problem? Well, there's a great trend that's happening at the moment. I've made these slides purposely vendor agnostic, but because there are actually several vendors that are using AI to try and fight this, and by security vendors and different areas. And I think this, as a concept, has a lot of promise, where we're actually finding these issues. And part of the problem with vulnerabilities in code is that if a developer creates a vulnerability in code, even if someone tells them that it's vulnerable, if they've put it there in the first place, they may not have the expertise to solve it. So having tools that actually help solve that problem for you is definitely something that we're going through, and there are a number of vendors that are actually starting to do this. So just to give you an idea of how that works, is that it finds a vulnerable code, and then it's able to actually create a non-vulnerable version of that and create a pull request for you. And so this is kind of where I see us finally being able to get on top of these legacy problems in code, is that when we're actually able to rely on the tools that we have, when they can fix the problems for us, because clearly we're not doing a great job of fixing them ourselves. So that's all I had for you today. I hope it was enjoyable with the memes, at least for the last session of the day. I tried to keep it short, but I hope you still found it useful. So thanks for listening, thanks for being here, and I'll be happy to chat to you afterwards. Yeah.
If you go back to the graph, machine learning graph, because perhaps I missed it or I was a bit confused because you said the injection with AI is less.
Oh, right. Sorry. No, I just got confused in my words. So the question was the injection was less. I was actually talking about the complete opposite. Well, the injection is much worse from the LLM than the baseline. That was, kind of the whole point. But it's 5 p.m. on a Sunday. My brain wasn't working. But thanks for pointing that out. Yeah.
So dependency is a real problem, right?
Yes.
I mean, do you know out of the different CVEs you've spotted how much are within dependency that we actually use day to day? Because I mean, for high level kind of like when I do the shitty code, right, that's a problem. But when I use a dependency that was written in a shitty way, that's a bigger problem. And I think like SAS and Dast won't cover that, right?
No, definitely. And dependencies are a massive problem in all of those open source tools that we're discussing. The limitations of what this research and the facts are given is that everything is weighted equally. So that also means that how popular the project is weighted, but it also means like how critical the vulnerability itself is equally weighted. So something that has like a 9.5 critical, I only used like critical and high. I ignored everything below medium, but still, like there's a big difference between the lower end of a high and then like a 10 out of 10 severity for the critical. So there is like a big limitation in that we need to kind of go further. And I think what would be interesting is looking at out of like the most popular projects, what are the ones that have had SQL injection vulnerabilities, and then also what are most critical. The results from that though will be a little bit skewed because when we're dealing with very popular projects, of course, it's the many eyes theory. They have more eyes on them, so you're going to get more vulnerability CVEs. So it's kind of will skew the results to look like, oh, the popular ones are bad, which won't be the case. It's just that the popular ones have more attention. But it will be interesting to look at that because dependencies are still a massive issue of why this is. And the supply chain attacks, we've seen what happened with Log4j. We almost saw what happened with XZ's utilis. So, like, thank God we didn't. As we can see, it's still not a solved problem.
Out of curiosity, did you check the percentage of vulnerabilities after you tweaked the prompt for the LLM to make it really secure?
Sorry, what?
So if you the prompt that you showed, did you check it after you if you tweak the prompt just to like make it very secure? Did you check if it makes anything?
This is okay. So you're the second person that's mentioned this, and I'm embarrassed on both times that I didn't because like LLM models are very smart but also really dumb. And so someone asked me like, what if I run this again, but at the end just add and make sure it's secure, will it change the results? And I haven't done it yet, but I will do it. And I'll be like really fascinated either way if it does. And it probably will. I think it probably will. These LLMs are just so literal in everything that they do. Because with things like hallucinations, if you ask it for a bunch of dependencies and you discover that they're hallucinated, if you ask it afterwards, can you check to see if you hallucinated them? It will say, oh yes, I did, sorry. So like clearly